Tantos were a popular style of knife used throughout Japanese history, not only for combat or utility, but for ceremonial purposes as well. Today, most people resort to buying plastic-clad sheet metal knives for daily tasks. While cheaper, they do take away from the beauty and craftsmanship of forging a knife from scratch. The Macsmiths, a McMaster University-based bladesmithing team, is attempting to bring some of that magic back and connect students with traditional forging methods. For the 2022 TMS bladesmithing competition, the Macsmiths team has decided to create a Tanto Kaiken style knife. First, the team began by creating a 3D model to which to reference in terms of shape and final assembly. This is a crucial step to plan out the project. This Kaiken blade was chosen to be made from a functionally graded material originally intended for ballistic armor. It was donated to the team and is a piece of hot-rolled nanobainetic plate, metallurgically hot-rolled to a softer and more ductile twip steel. Due to its hardness, the material needs to be sectioned before forging. By firing up our hand-built air coke furnace, the slab of material was placed inside and heated up to approximately 1100 degrees Celsius. Team members made sure to take great care around the furnace, not to come into contact with the hot metal and furnace bricks, following forge rules and wearing the necessary protective equipment including goggles, heat-resistant gloves, masks, and steel-toe boots. Unfortunately, not all blades are perfect, and the furnace became hot enough to melt the blade. After some tweaks to the design, the team kept going to get the most out of the material. Wearing the proper protective equipment, team members used grinding wheels and a belt sander to remove unnecessary bulk metal and oxide on the surface. Once a finer shape is achieved, the blade is brought to a furnace room for heat treatment. In accordance with Japanese methods, a clay shell was put on top of the blade so that a different cooling rate could be achieved between the blade edge and the spine. Team members wearing full protective equipment removed the blade from a box furnace once it was held at 900 C for 5 minutes in order to quench it. This quench was done in oil as to lower the heat transfer rate and minimize quench cracks. This process also introduced some oxides on the surface and means the blade is once again ground. Once that was done, the blade should have increased hardness, and this was confirmed with a Rockwell hardness test. Meanwhile, another team member started working on the handle at this time, taking one cherry block and squaring it to carve out a handle and a sheath. Using safety equipment, they carved the handle to the desired shape. To make sure the handle stays in place, additional brass pieces were cast. This included a pin and a guard, or cast and ground down to proper sizing for the blade assembly. The blade was acid etched with 2% nitrile, cleaned up, and then ran through a multitude of whetstones in order to improve the final finish of the blade. After this was done, the blade was assembled, with all pieces fitted together with glue and ground smooth, and the wood was stained and finished with beeswax.